m, a particle of mass m moving with velocity u collides with the rod. Find the velocity of the rod just after impact for following cases: E equal to 0, E equal to 1, E equal to 0.5. The moment it collides, this is very important. Injured rod. The rod is injured. So the particle will, first case we'll discuss, E equal to 0. The particle will get stuck to it. What can happen? What will happen here? This will exert impulse, and there'll be impulse. This impulse acting on this rod, what it will do? It will make the rod to move. No, it will try to make the rod to move vertically. G is acting here. I think I make vertically suspended. Able to understand how the weight will act vertically down. In gravity, it's suspended. Now this impulse acting, what it does? It will make the rod to move. No? The rod don't know it's suspended or not. Because of impulse, it wants to move. So this hinge will not permit. In what direction the hinge will exert force on the rod? Say I want to move. Suddenly somebody pulls. Tell me in what direction experience force towards left. So this was the hinge force. Are able to understand? There's a reaction at the hinge. What is Jx? Reaction at the hinge. And also because of this impulse J, it is hinged about point. There's a fixed axis rotation. It will acquire angular velocity. It will acquire angular velocity. And because of this angular velocity, already weight mg is acting, and suddenly a centrifugal force will act. No, so therefore the weight of the rod and centrifugal force will try to pull it vertically down. So suddenly what happened? Earlier, see, mg is acting. Now there's a reaction. Ry is equal to 2mg. Then because of suddenly what happened, along with the 2mg what happened, a sudden what happened, centrifugal force will act. So a reaction is set up here. So again we'll get also jy here. Every problem, this is very important. The how to calculate the reaction at the inch, reaction at the inch. This is a thing. Okay, let's come for this one. Can I conserve linear momentum? Look at, you have in front of thing everything. Why Jx like this? Because of the condition I'm assuming here. No. Can I conserve linear momentum? The answer is no. Because plus J minus J. What about this Jx is unbalanced on the rod plus particle system. So therefore momentum is not conserved. Then angular momentum, shall I consider about any point on the rod or about center of mass of system? Somewhere here it will come. Or about any point on the ground. Where is the ground? The ground is here. About any point on the ground. Or about any point on the rod. Or about center of the rod or center of mass of system, or about the hinge only. If I take the axis of rotation here, then what when the impulse due to jy and jx will intersect axis of rotation, there won't be angular impulse due to this. There'll be an angular impulse due to this plus jl minus jl. So what is net angular impulse? 0. So therefore angular momentum is conserved about point of suspension. Let me call that as A. O. So angular momentum is about what point conserved? About A only. Not like earlier problems. Angular momentum is conserved about any point on the rod, about the center of the rod, about center of mass, or about any point on the ground. No, not like that. It is conserved here only about point of suspension. Why? Because the net impulse will be 0. So, but this J is there. S plus JL minus JL. R bar, it will set up torque like this. R bar J anti-clockwise. So, here I'll write it LAZI equal to LAZF. First case we are discussing, let me do like this. This is the first case. E equal to 0 we are discussing. I think I'll write it here only. Let me write it here. So what is the equation? LAZI equal to LAZF. Initial angular momentum about point A due to only particle MUL. Yeah. Next again, final angular momentum of system IAZ into omega. What is IAZ? MUL is equal to moment of inertia of the rod 2m L square by 3 plus moment of inertia of particle ml square into omega. So I got the omega. Omega is equal to how much? 3u by 5l. What about the sense of this? Anti-clockwise, as shown in the diagram. At that instant, what is the velocity, linear velocity of point O? Linear velocity of point O should be L by 2 omega. What is the velocity of particle? We can calculate all, no? Different points on the rod will have a different velocity. Directly, you go for moment of inertia of the system, rod plus particle. This is rod. This is rod. This is for particle. And now what happened to rod after this? It starts rotating. No? Now I'll ask you a few questions. With what speed the particle should come so that the rod will become horizontal? Then what you should do after this? You should apply conservation of mechanical energy. You should apply conservation of mechanical energy. From here, initial kinetic energy of Ia omega square by 2. That should be equal to increase in gravitational potential of system. Rod plus particle. Write that equation. Let me describe that idea here. The rod is here. And finally, it will become like this. So there's the particle. No? No. What should be the initial velocity of the particle? For that to happen, we know omega in terms of u. Now I'm going to apply the formula like this. Moment of inertia 2m L square by 3 half into plus ml square into omega square. This should be equal to what? Increase in gravitational potential. How much 2m will ascend? 2mg L by 2. How much m? M will ascend by height L. Will get the required omega. That omega will substitute. That should be the initial velocity of the particle. They can ask you like this also. After collision or when the rod plus particle, they rotate. Let me introduce here only. Note. To what height? So depending upon the omega open, it will height it. So my question is like, after getting omega, then what should be the required speed of the particle so that after collision, the rod will become horizontal. So we can find out the. Sir, can it complete vertical circle? Yes, it can complete vertical circle. In that case, what you should write? This should become L and this will become 2L. Then with that speed, the particle should come in collide. You say this is the equation. Don't change anything. This will be as it is. So to what position the rod will attain, that will determine the omega. That omega will substitute, that will be the speed of the particle. So there's a very fundamental problem, not like a numerical, it's a theory. Whenever a rigid body is suspended vertically in the gravity, then about what point you should